8.5. Use properties of trapezoids and kites. Essential question. What are the main properties of trapezoids and kite? First of all, a trapezoid is a quadrilateral with exactly one pair of parallel sides. A trapezoid can best be represented with a sketch like that. An isosceles trapezoid is a trapezoid with congruent legs. So again, if I like that makes it a trapezoid. That's what a isosceles trapezoid is defined as. A mid-segment of a trapezoid is the segment formed by connecting leg midpoints. A kite, picture a kite, a lot of people used to fly them in the springtime here. Another kite could be like this. Those are two examples of a kite. One of our skills is being able to plot points and determine some features that will distinguish it as a quadrilateral. So -3, 2, 3, 0, 4, 3, and -2, 5. So here's my A, B, C, and D. So we'll connect them in this fashion, and we're supposed to show that it's a trapezoid. So we're looking at one pair of parallel lines. The slope from A to B goes 1, 2, 3 down, 1, 2, 3, 4, 5, okay. Let's back that up. It does not go 3 down. It goes 2 down. 1, 2, and then 1, 2, 3, 4, 5, 6. So its slope is -2 plus 6. We'll leave it like that for now. BC, it looks like I went up 1, 2, 3, and over 1. So it looks like 3 over 1 for the slope. From C to D, I go up 1, 2, but then left 1, 2, 3, 4, 5, 6. So I went +2, but left 6, so that's a -6. So these are parallel. And from A to D, it looks like I went up 1, 2, 3 over 1. 3 over 1, so those are also parallel. So not a trapezoid. Two pairs of parallels. Now this is actually a parallelogram, but it's also a rectangle because the slopes are opposite reciprocal, so they form right angles. A couple of theorems. If a trapezoid is isosceles, then each pair of base angles is congruent. If I go ahead here, trapezoid, isosceles, if I have that, it's going to be isosceles. Okay. If a trapezoid has a pair of congruent base angles, let me finish this off here. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So it's the converse of theorem 850. Moving on here, one additional isosceles trapezoid theorem. If its diagonals are congruent, one of the same features of a rectangle. So if I go ahead and sketch a pretty nice trapezoid, if this diagonal is congruent to this, usually depicted like that, then that's an isosceles trapezoid. A2 here, figure out the measures of A, B, or B, C, and D's angles. First of all, it's a trapezoid. It's isosceles, so that means this angle is congruent to this, so this is 97. Since we have parallels, then angles here and here are supplementary, so this is 180 minus 97 for 83 degrees. And again, this angle is congruent to this, so this makes this 83 degrees as well. A3, a proof to show that we'll have diagonals that are congruent. I'm going to go ahead and sketch. I've got trapezoid golf with GL and FO being parallel, so GL, okay, let me go ahead and redraw that, so they're congruent. Alrighty, let's restart here. I've got trapezoid golf. We're supposed to prove that GL is congruent if we have GO and LF congruent. So if I have this congruent to that, then we're trying to get to the diagonals here. Okay, try to get my diagram set up right. First of all, I have some givens here. So I've got isosceles trapezoid, and I've got GO congruent to LF. Reason it's given. Okay. Because it's isosceles, I can go ahead here and say that the space angle here is congruent to the base angle here. So I can say that angle G is congruent to angle F. And that is a previous theorem here. And let me just go back and see what theorem that was. Must have been theorem 814. I can also say that GF is congruent to GF. One of our old friends, the reflexive property. Now because of that, I could say that this triangle here in black is congruent to this triangle here in red because of side angle side. So triangle GOF is congruent to triangle FLG by side angle side. And then we can finish off by saying that this long side is congruent to this long side. So now I can say that GL is congruent to FO because the corresponding parts of congruent triangles are congruent. to mid-segments here. A mid-segment, if we go back a few screens here, we have a mid-segment here. And one thing that we can mention is that the mid-segment is in fact parallel to the other bases, so it's parallel to the bases. And if this was 20 and this was 14, this would be 17 due to the next theorem we have. Okay, let's go back to that theorem. So here we want to say the mid-segment of a trapezoid is parallel to each base, and its length is the average of the base lengths. Now remember, average is taking the sum of the bases and dividing by 2. So in this case here, perfect example here, I'm looking for this thing here, we can call it x. I can go ahead and say x equals 21 plus 17, those are 2 bases, divided by 2, 38, divided by 2 is 19. And it's also parallel. Okay. Theorem 18 switches over to kites. Remember, kites look like this. And a kite has consecutive, congruent, distinct, 2 pairs of sides. So, a kite, then its diagonals, if I sketch in the diagonals in my nicely sketched, we also get perpendiculars, similar to a rhombus. All right. So we can use this here. We'll use that here in a moment, but Theorem 819 says again, if we have a kite, then one of its diagonals, the diagonal that connects what we call the vertex angles, will bisect a pair of opposite angles. So if a quadrilateral is a kite, then exactly 1 pair of opposite angles are bisected. Alrighty here. Finding these 2 angles of kite here for A5. First of all, we do have a pair of congruent sides here, or congruent angles. So to find this angle, I'm going to take 360 for a quadrilateral, minus the 2 that I know, and divide by 2. So we get 250 divided by 2, we get 125 degrees. So 125 here, 125 here. The last one we're going to do here is finding the missing length and the missing angle here. Well, first of all, VST, x here. So I can use some inverse trig here. I can say the tangent of x equals 9 over 8. I'm going to do some inverse trig here. So if I do inverse tangent, and x is about 48 degrees, multiply by 2 for the 2 x's, I get 96 degrees. Find the other one, use the Pythagorean theorem with these guys right here. Got to stop there. This is section 8.5.